Hello children, good morning all of you. Today for class 12, ISC and West Bengal Board. Linear regression part 2. That means you have already got one lesson. You must go through that lesson. There are formulas and method. Now please pay your attention on the board. Sums given from ML Agarwal's book exercise 2, sum number 6, part 1. Out of two regression lines, you will get in your book, and here also it is written clearly. Pay your attention on the solution. We know that r square equal to coefficient of regression yx into coefficient of regression xy less than equal to -1. In case of perpendicular, what you have learned at class 10 and 11, the condition of perpendicularity, that is product of the slope equal to -1, that is m1 into m2 equal to -1. Here coefficient of regression yx and xy less than equal to 1, not minus and equal to 1, not more than 1. This is the condition. Assuming 3x plus 12y equal to 8 to be the regression line of y on x, we have, this is the line given, we have to find out the slope. This is why we have to convert into gradient form, y equal to mx plus c, y equal to mx plus c, that is in place of m we are getting -4. This is why byx equal to -1/4. Then 9x plus 3y equal to 46 is regression line on x on y. This is y on x, this is x on y. This is why 9x we are keeping left hand side, and by simplifying we are getting the coefficient bxy equal to -1/3. Now by product, that is yx and xy, by calculation it is coming -1/12. -1/12, that is less than 1, is less than 1, so that it is possible. Less than 1, here less than equal to 1, equal to 1 and less than, it is less than, so it is possible. Hence our assumption is true. We have the line of regression of y on x. y on x is 3x plus 12y equal to 8. This is the y on x, that is equation 3x plus 12y equal to 8. This is y on x and this is x on y. But that is not required. In the sum, y on x is required. Therefore, 3x plus 12y equal to 8 is the answer. Next sum. This is given from R.D. Sharma's book. Out of the following two regression lines, find the line of regression on x on y. This is y on x and this is x on y of this equation. Solution. In such cases, same thing, different way we may express. In such cases, in the fact that the product of the coefficient, regression coefficient less than equal to -1, less than equal to -1. Here assuming x plus 4y, x plus 4y equal to 3 to be the regression line of x on y. Here x on y. We have to convert into gradient x on y. This is why we are keeping x first. X on y, and this is, we have find, that is y on x. Y on x, this is y on x and this is x on y. This is why x we are keeping first, and in this way we are getting the slope, not slope, that is regression coefficient -4. Definitely this is slope -4. Then 9x plus 3y equal to 16 is regression line of y on x. Y on x. This is x on y and this is y on x. So by converting in gradient form, we are getting the coefficient of regression, that is slope, equal to -3. Now product of these two coefficient equal to -3. -3 and -4. By calculation it is coming 12. Greater than 1 is greater than 1. So it is not possible. Greater than 1 is not possible. That is less than equal. Logic we have to follow. Less than equal to 1. Equal to 1. It is so it is not possible. Greater than, this 12 is coming, that is greater than 1. So our assumption is wrong. Thus x plus 4y equal to 3 is not is the line of regression of y on x. Y on x, but our question is x on y. We have to find out x on y. This is y on x. There, this is y on x. So next line, that is 9x plus 3y, will be the x on y. Therefore, the line of regression of x on y is 9x plus 3y equal to 16. Logic you have to follow attentively. This is not possible, so it is not the regression line, that is y on x. This is y on x, but x on y. X on y. So naturally, if it is not the regression line on x on y, naturally this will be. This is why we are writing answer. The line of regression of x on y is this. I think it is clear. If you feel difficulties, you very simple, no doubt. Ishan and Jishnu and others, if you follow the step attentively, then easily you will understand. Okay, thank you everybody.